Okay, let's have a look. So close those up, put them all the way closed. I won't take too much of your time, but it's pretty clear that where people are having the most trouble is on this stuff, on solving linear systems. Thank you. It's linear quadratic systems. So click and close, get out your notes, take a look, turn face to front, let's have a look here. So what are we going to do? If we're solving these algebraically, what are we going to do?
Isolate the variable.
Okay, good. And which variable are we going to isolate here? Y, yeah. We're going to isolate Y. So we want to be able, there's a Y and there's a Y. It's easy to isolate the Y in the bottom equation and substitute, right? So what are we going to get if we isolate Y from the bottom equation? Y equals what? So there's our substitution equation, right? And then we'll just substitute into there, right? So we end up with what then? X squared on the left instead of a Y. We're going to have 5x minus 5, thank you. And then we've got this additional minus 5, oops, sorry, plus 1. Make sense? Okay, now what do we do from here? Combine like terms, good. So we could make the minus 5 plus 1 a minus 4, right? Now what?
Make it equal to 0.
Set it equal to 0, good. Which side do we want to push everything to?
Right.
To the
The left. How come the left?
because x squared is positive.
Because we want x squared, positive number of x squared. So we subtract 5x, we add 4, and then we just got a quadratic equation, right? And that's, how would we solve this one? Let's think about this in terms of, everybody got one of the flow charts, right?
Yeah.
Okay. Let's think about it in terms of that. Can I isolate x? No. Is a bigger than 1? No, a is 1, right? So it might be easy. B is negative, so I don't want to complete the square. Agreed? So if we thought of this in terms of what all our methods are, isolate x, factor, complete the square, or quadratic formula, we can cross them off, right? We know we can't isolate x. B is odd, so we know we're not going to complete the square. And so really what's left? I mean, if we can pick magic numbers, we'll factor, otherwise we'll quadratic formula, right? Are there magic numbers?
No.
That
Yes.
multiply to positive 4 and add to negative 5? Well, there are. What would the signs be?
Oh,
Both
both
are
negative.
negative.
They'd both be negative, good, because they have to multiply to a positive and add to a negative. And what are they?
1 and 4.
1 and 4. So that would be the easiest method then, would be to factor, right? So we end up with what for our solutions? X equals 1 or 4. Okay, are we done?
No.
Nope. What else do we have to do?
Solve for 1.
Good, we gotta find y, don't we? So we'll go back up here to the boxed substitution equation and we'll solve for y. If x is 1, what do we get? 5 times 1 minus 5 is 0. Okay, so we get the point 1, 0, or what about if x is 4? 15, yeah, 20 minus 5 would be 15. So those are our two solutions. We can check them by plugging them back in. Okay, no big deal. How about this? A little bit tougher. What are we going to substitute for here? For y. Okay, good. So we've already got a substitution equation right there, right? We just plug that into the top equation, and what do we get? So the top equation is minus y, but what are we going to plug in for y?
3x plus
3x plus 7. And then we have minus 2 equals the quantity x plus 3 squared. Okay, now what? But now, Robert, what's next?
Square root.
No. No. What do you think? Savannah? What's next? Any ideas? Distribute, yeah, good. Let's distribute the minus, right? Because think, what are we going with this? Our goal is we want to get this into standard form, right? We want to turn this into a quadratic equation in standard form. So it's equal to 0, and then we'll take our pick. We'll just solve it the easiest way. But really, that's the first thing we got to do is get to there, right? So we'll distribute the negative sign. That's just going to make both of those negative, right? And then over here, x plus 3 squared. So now we're just simplifying, right? On the left side, what can we do? Combine like terms. Negative 7 minus 2 is what? Okay, what about the right side? Well, let's go ahead and do the right side in the same step. Because we got to do some stuff there. That doesn't look like that.
Or can you,
We've got to break it up, don't we? We've got to expand that out. So what are our options? How do we expand out x plus 3 quantity squared?
X, well,
Ax squared.
a squared minus 2ab.
Okay, so we could use, the pattern is probably the best way. We'll do it that way. If we forgot the pattern, what could we do in a pinch here?
X
Do.
plus 3 times x.
X plus 3 times x plus 3, distribute, add like terms, right? It's always going to work, but it's better to use the pattern if we can remember it. So the pattern, this is a plus pattern, right? So what's our plus pattern? Shannon, what is it?
A squared.
A squared
2
plus 2ab
B squared.
plus b squared. Good. So then, instead of an a, we have an x. Instead of a b, we have a 3. So what are we going to get on that side then? What's that going to be? Vincent, what are we going to get? So instead of a squared, we're going to have what?
X.
X squared. Good. Instead of 2ab, what's that going to be for us?
6.
Yeah, you're right. Say it again. 6x. Good. And then instead of b squared, we're going to have, which is 9. Good. Okay, good. It's looking better, right? Now what? What's next here? You Randy, what are we going to do next?
You gotta put the 6x and the 9 on the other side.
Okay, so we want to put everything on one side, right? Good. Which side now? Think carefully here. Which side do we want to put everything on?
Right.
Okay, good. How come? Because we don't want a negative x squared. Good. We want a positive number of x squareds. Good. So we'll add the 3x. We'll add the 9. And then everything cancels over here. And on this side, we're going to get x squared plus how many x? Good. 9x plus 18. And the zero's over here. But really, I mean, why do we want to put the 0 on the left? Why not just instead? Because we know this is all equal to 0. Isn't it easier to think about if we just do it this way?
It doesn't make a difference. On the
Makes no
side.
difference, right? It doesn't make any difference. That's probably the way we're more used to seeing it. Okay, now what? How are we going to solve this one? What are our options here? So can't isolate, right? Next easiest one would be factoring, right? Well, a is equal to 1, so factoring, can we find magic numbers that multiply to positive 18 and add to positive 9?
3 and 6.
3 and 6, yeah. So Robert, what are our solutions then? Either we get x equals,
3.
well, but hold it now, we're using the zero product property here, right? So we gotta know when the product of the left factor times the right factor is 0 only when we're multiplying by 0. So either that one's gotta be 0 or that one's gotta be 0. What's the x value that makes the first factor 0?
-1. -3.
Negative 3. How about the second one?
-6.
Negative 6. And then we can just go back to our boxed equation. Y equals 3x plus 7. Okay, so then what if x is negative 3? What's y going to be? What do you think? Kinsey, if x is negative 3, we plug that in, what are we going to get for y? 3 times negative 3 plus 7.
I don't know. Negative 2.
Ready? Negative 2, good. We get negative 9 plus 7, negative 2. Or the other one, if we plug in negative 6, go ahead, Brittany. 3 times negative 6 is plus 7, negative 11. So there are our solutions, right? Okay, good, good. What if we add just a little bit more difficulty to this? So this one, what's the problem with this one? I mean, we can do this a bunch of ways, but we want to make this as easy as we can. What do you see as the problem, Dustin?
There's 2 variables in the equation.
There's 2 variables in the equation, and if I try to solve for x or y in either one of these, what's going to happen? I'm going to end up with, well, negatives maybe, but even worse than that. Jeremy? I'm going to get in fractions, right? Like probably I'd want to maybe solve for y, but if I solve for y here, I'm going to add the 3x to the other side and divide by 2, and I'm going to get at least one fraction in there, right? Does anybody see maybe a little trickier way to do this?
Just solve for 2.
Yeah, just solve for 2y, right? All we have to do is find the same thing in this equation that we have in the other equation, and then if I isolate the orange bubble here, it's the same thing that's in the orange bubble there, right? So if I isolate the orange bubble here and set it equal to something, I can substitute for that, right? So in this equation, if I solve for 2y, what do I get?
Negative 30 plus 3x.
I'm going to add the 3x to that side. Good, so I'm going to end up with 3x minus 30, right? Okay, and that's pretty easy to substitute then. I'm just going to substitute all this stuff right there, right? See how that works? So we end up with, in the top equation, x minus 8 squared equals 2y, which is 3x minus 30 plus 6. Okay, that's not too bad, right? Now all we got to do is combine like terms, and we just need to expand that out and simplify, right? Turn it in, put it in standard form. We won't even do the whole problem. We'll just see if we can get it set up to where we can solve this pretty easily. So we end up with what? 3x, what's negative 30 plus 6? Negative 24, okay, good. Uliana, if I wanted to, what's next?
Would you solve in parentheses?
Okay, good, I'll simplify that one, I'll expand that out. So see, can you tell me what that's gonna be without even, I mean, just thinking about that pattern? I'm gonna, x squared, good.
64 or plus 64?
Okay, that's gonna be at the end, right? But if we're gonna do our pattern, this is gonna be the minus pattern, isn't it? So I get a minus b squared. Remember what that pattern is? A squared minus 2ab plus b squared. Okay. So the 64 is going to be there. That's going to be the b squared part, isn't it?
It is.
But what's that middle term going to be? The minus 2ab. And really all you got to think about is it's the first squared, in this case minus 2 times the first times the second, right? And then always plus the last one squared. What do we get in the middle? What's 2 times x times 8?
60x.
Good, right? So there's the left side expanded out. There's our right side. JJ, what are we going to get if we put everything on one side? Minus 19x, good. Because we're subtracting 3x from both sides, right? But hold on, I'm adding the 24, right?
Then 88.
88. Okay, there we are, right? So let's see. Lauren, what am I gonna probably do here? I can't isolate X. Okay, question. Oh, okay. Magic numbers, yeah, there are magic numbers, aren't there? Now, if you don't see them, you could always quadratic formula this thing, right? But what are they? What are the magic numbers that multiply to positive 88 and add to negative 19? Anybody see them?
Negative 10, or negative 11, negative 8.
Yeah. Yeah, so you could do x minus 11 and x minus 8. Now, if the magic numbers start to get too hard to find, though, what do? Plug them into the quadratic formula. Yeah.
Yeah.
Baseball, softball. All right. Good luck.
Guys.
Softball. All right.
Bye, Kyrie. Good luck. Go luck.
So last couple steps would be what then? X equals, or X equals, and then we just plug back into, oh, actually, let's go ahead and do this, because there's one little thing here that I want you to see. So either we get X equals 11, or X equals 8, but this time, look what happens if we go back to our boxed equation. Our boxed equation was 2y equals 3x minus 30, right? So that's not super convenient, but it's still not bad, right? If I plug in the x values, it's pretty simple to solve for y, isn't it? Everybody agree? So if I plug in x equals 11, for example, we'd end up with 2y equals 3 times 11 is what? 33 minus 30 it would be 3. So what's y? Yeah. Right? So we get the ordered pair 11 3/2. What about if x equals 8, if I plug that in? I'm going to get 2y equals 3 times 8 is 24 minus 30. Negative 6, good. So what's y? Negative 3. Negative 6 divided by 2 is negative 3, so we get 8, negative 3. Make sense? Okay? I want you to work. We do this period of work.